5.2. This is verifying trig identities, and what you have on these kind of problems is you already have the answer, and you just want to prove that the left side of the equal sign equals the right side of the equal sign. And so the way to start these problems is you want to work on just one side at a time. Either make the right, in this case the 1, show that it's equal to that, or you show that sine squared theta plus cosine squared theta divided by cosine squared theta secant squared theta is equal to 1. And usually what you want to do is start working on the more complex side. So that's what we're going to do. So let's look at the numerator, sine squared theta plus cosine squared theta. Well, we know that's a trig identity. That's equal to 1. So we have 1 over cosine squared theta secant squared theta. So we know that the secant is 1 over cosine. So we have 1 over cosine squared theta times 1 over cosine squared theta. And so that's equal to 1 over 1, which is equal to 1. When you get the answer, you just kind of check it and make sure that that's what you were trying to find. Okay, so there's many ways to verify these. So different approaches, you can arrive at the same answer. So not all of you are going to solve it exactly the same way. And the issue here is if you get stuck, just erase it and try something else. So let's look at number 2. Notice on the left-hand side, this is kind of an algebraic form of A over B plus C over D. And we know that that is equal to AD plus CB over BD. So that's what we're going to do with this. So we bring this times that. So that gives us 1 plus cosine beta, then plus this times that. So that's a 1 minus cosine beta all over 1 minus cosine beta times 1 plus cosine beta. Okay, so if we look at the numerator, we have plus cosine beta and minus cosine beta, so we can cross those two off, and we're left with 1 plus 1 is 2 in the numerator. And then we multiply the denominator. These are conjugates of each other. So it's going to give us a 1 minus cosine squared beta. So 1 minus cosine squared beta, well, let's first take care of the numerator. So we have 2 in the numerator. And we recognize that 1 minus cosine squared beta is a trig identity, and that is sine squared beta. And we know sine squared beta is 1 over cosecant squared. So that gives us 2 cosecant squared beta. And that checks with the original. All right, problem number 3. Verify secant squared x minus 1 times sine squared x minus 1. And we want that to be a negative sine squared x. So let's look at the first one. Secant squared x minus 1, we recognize that as tangent squared x. And then the sine squared x minus 1, well, we know that a 1 minus sine squared x equals cosine. So if we have a sine squared x minus 1, that's going to equal a negative cosine squared x. Okay, so now we have a tangent squared x. We're going to change that to a sine squared x over cosine squared x. And we're going to multiply by a negative cosine squared x. So the cosine squared x's cancel, but we have a negative still. And so that's just going to give us a negative sine squared x. So agrees with our original, so we did that. All right, example number 4. Verify cotangent x cosine x equals cosecant x minus sine x. And so you might want to think about which side you want to start on. We could start on the left, try to make it look like the right. But in this case, I think the right-hand side is maybe a little more complex. So we're going to work on that first. So a cosecant x, well, that's a 1 over sine x, and minus sine x. So I'm going to multiply top and bottom by sine x on the right-hand side. So sine x over sine x. That way I can combine this into one fraction. So I'm going to have a 1 minus sine squared x over sine x. So I recognize that the 1 minus sine squared x is cosine squared x. So we have a cosine squared x over sine x. Now, what should I do with this? Well, I'm going to break up the cosine squared x into two terms. So cosine x times cosine x over sine x. And then I know that the cosine x over sine x is 1 over tangent x, which is cotangent x. So then I have a cosine x cotangent x. And that is my answer, and it's the same as the original. So I approached this using or manipulating the right-hand side. You can do the same thing with the left-hand side, and actually it may be easier, I'm not sure. But once I got it on by manipulating the right-hand side, I verified it, and we're done. Now, let's say I kept going on the right-hand side and I couldn't get anything to look like the left-hand side. So what I would do is just start over and try to make the left-hand side equal the right-hand side. So you may get into a problem where that's what you're going to have to do. Okay, the fifth example, we have a cosecant beta plus cotangent beta equals sine beta over 1 minus cosine beta. Now, this 1 minus cosine beta looks close to a trig identity, but it's not a cosine squared. So what you can do is just multiply top and bottom by the conjugate. So we're going to multiply 1 plus cosine beta over 1 plus cosine beta. And what that is going to do in the denominator, it's going to give you a trig identity to work with. So the numerator, I'm just going to leave it sine beta. Sometimes it works when you multiply it out, sometimes you don't need to. So I'm going to not multiply it out. 1 plus cosine beta. And the denominator, since they're conjugates, we know it's going to be a 1 minus cosine squared beta. So the denominator I know is going to be equal to a sine squared beta. So let's see, this is going to be sine beta times 1 plus cosine beta over sine squared beta. Well, I can cancel the sine beta and the sine squared beta. So that will cancel the squared term. And so that leaves me with 1 plus cosine beta over sine beta. Oh, looky here. That's exactly what I started with. So now let me redo it. So I'm going to come over here and I'm going to rewrite this. Oh, I take it back. Never mind. This isn't what I started with. I just kind of glanced at it and go, oh, that's the same thing. Well, it's not. So I don't know what I was thinking. So anyway, I'm going to take this 1 plus cosine beta over sine beta, and I'm going to make it into two fractions. I'm going to split it up. So I'm going to have a 1 over sine beta plus a cosine beta over sine beta. Okay, so now this is getting me where I want to go. 1 over sine beta is cosecant beta. And cosine beta over sine beta is a cotangent beta. And that's my answer. That's what I was trying to find, because that is the same as this. Okay, so that's almost thought I messed up, but apparently I didn't, because I got the right answer, so I'm good. All righty, our last example. Verify tangent squared theta over 1 plus secant theta is equal to 1 minus cosine theta over cosine theta. So it looks to me like the left side of the equation is a little bit more difficult. Plus, I know right away I can make that tangent squared theta into a trig identity. So that's the side I'm going to work on. So tangent squared theta is a secant squared theta minus 1 over 1 plus secant theta. So now I'm going to, well, I recognize that the numerator here is a difference of 2 squares, so we're going to unpack that. So this is going to be secant theta plus 1 times secant theta minus 1, and this is all over 1 plus secant theta. All right, well, this looks like it's going to simplify quickly. We have a secant theta plus 1 and a 1 plus secant theta. Those will cancel out. So we're left with secant theta minus 1. So now, okay, recognize that the secant theta, we can change that to a 1 over cosine theta. And we have a minus 1. And if we multiply this minus 1 times cosine theta over cosine theta, well, then we have in the numerator, we have a 1 minus cosine theta. The denominator is cosine theta. So that's what we're trying to get. We got it, and it looks like that, so we're good. Okay, so that's all the examples of 5.2. Just remember, when you're verifying these, you're going to use trig identities and some little bit of algebra skills to try to make the right-hand side look like the left-hand side or vice versa.